In this video, I want to talk about the edge detection in noisy images. First, the author reviewed all the old edge detection algorithms. First, um, he reviewed when we do the edge detection, we normally we apply a Gaussian filter and to make it smoothie. And after that, we use the edge detection algorithm, for example, the Canny algorithm. However, the author said when we smoothing the image, our purpose is to remove the noises. But when we smoothing it, the edge becomes blurry. So it's making even hard to find the actual edge. After that, he reviewed this edge detection algorithm, and this edge detection relies on local gradients. So if the uh, noise the image have too much noise, is have some limits here. It's not very accurate. And then he reviewed more algorithms, and most of them are not very good when we try to detect the long, faint edges or the uh, small fibers. And this here are some new edge detection algorithms, and they are very good at detecting the natural images. They use a histogram intensity and try to differentiate different histograms on different sides of an edge. Even though they work wonderful on the natural images, but for some picture like this, the electronic microscopy images, they are not very good at that. And also, most of the algorithms are slow, and um, and okay, and after that, people use some more more faster algorithms, and they depends on deep learning. And in this article, the authors introduced a new method of the edge detection. So, and this is the whole algorithm. It looks very easy, but every step has a lot of mathematics behind it. So for each length of a curve, from the minimum length to maximum length of all the curves in one image, first we want to compute the response of the curve. If the response is less than t, and from my understanding, the t means true. So if it's less than t, it's false. So they don't have the response, and discuss that curve. If that curve is larger than t, and so it's true, it have a edge. So we can further to detect the edge based on some more algorithms. And that's it. For here, the author gives some example of the how to detect the edge. First, we have a line here, and the length is 4. This length is the maximum of the difference of the x and difference of the y. So this length is from 0 to 5. So the y here is uh, is considered as a length. And we also apply an filter with a width of 4. So it's 5 by 5 filter applied to the to the line, and we can calculate, well, based on some very expensive math, and we get the result here. So now when we have a line like this, we can detect different sides have different values of the edge. And the other thing is here, when the line is more than 45 degrees according to the x-axis, it's considered as vertical. And if the line is less than 45 degrees, it's considered as horizontal. So vertical line and horizontal line, they also give two different algorithms. And for the exactly 45 degree, the author put it on both sides. And here the author talked about how to detect the curve. Instead of a line, it's become a curve, and apply some algorithm here. And because my math is not that good, so this part I just skip it. And after the author did everything, the edge detection looks pretty good now. And the results here, they also compare different results of the image, and from top to bottom, this one is the author's algorithm, and this one is a Canny algorithm, and the last one is COB algorithm. Actually, when I look at these pictures, the author's algorithm is definitely works pretty well. But the COB algorithm looks also nice. Yeah. It has some false positives, but at least it can detect all the edges and show some details here. And even here, it has some details. And for the fiber detection, it means very thin and short edges. The author's algorithm works pretty well, and it can detect all the thin edges here. But for this picture, because the edge is a little bit thicker, so the Canny algorithm can work well on this image. Okay, and here this line is the ground truth. So the author's algorithm run on different images. It can generate some results very similar to the ground truth. And the most difficulty part is part 5 to part 7, and all of them are some very basic mathematics, and they also try to prove that his algorithm is correct. But I cannot really understand what they are doing here. Yeah. Hard to read. Okay, thank you.